Very good. Very good. That's too much noise. Okay, Elizabeth, lead us in an opening prayer for this lesson.
Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit.
Amen.
Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, as we forgive those who trespass. Lead us not into temptation, but deliver us from evil. For the kingdom, the power, the glory are you, now and forever. Amen. Good Father, thank you for the gift of life. Thank you for the love and protection that you have given us. Thank you, Lord, that we are still alive up to this moment. Thank you, Lord, that for us we have got a chance to have Zoom classes, but others have not got. Father, we thank you also for that. We thank you for our teacher that as we are going to listen to him, may you open our ears. May you give us your knowledge that you gave to King Solomon. Father, may you plans of the devil that is come and will destroy the network. Father, we ban them in the name of Jesus. Continue putting those who are going to join. Father, may you bring them together. Pray all this, believing and trusting in thy name. Amen. In the name of the Father, the Son, and of the Holy Spirit.
Okay, members, I think, are you getting me? Are you getting me?
Yes.
Okay.
Yes.
All right.
Yes,
So,
teacher.
all right. So, it's unfortunate, but I thank that you have not been hearing me and I've been talking. So, so you should know that there are very many words that I've spoken in the last 3 minutes. But let me repeat what I've been saying. So first of all, I thank Elizabeth for the beautiful prayer that you gave us. And also, I wanted you to know that we are looking at heat. So there are very many subtopics that we have looked at. We have looked at thermometry, where we have heat, how to determine the heat energy using a thermometer. Also, how to determine the heat energy using very many other thermometers, and also how to calibrate the thermometer, how to get to the lower fixed point, how to get to the upper fixed point, and also how to put the scale on the thermometer. We also looked at the heat transfers, and before heat transfers, we looked at how we can convert the temperature from degrees Celsius to Kelvin, and also from Kelvin to degrees Celsius. Now, previously, in the beginning of this week, we looked at the heat transfers, and one of them we looked at conduction. So that conduction, the transfer of heat from the region of high temperature to the region of low temperature in solids, but without movement of matter. And we say that there are many materials that transfer heat. Some of them are good conductors, others are bad conductors. And we say that the bad conductors do not transfer heat because they have bound electrons, or because they have immobile electrons. Their electrons are not free to move, whereas the good conductors, like metals, conduct heat faster because they have free mobile electrons, and that's why metals are good conductors of heat. We looked at where those conductors are applied. They're applied in different things that we have at home, utensils, from the flat iron, from the electrical wires, we have insulators, from the hot utensils you have in the kitchen, like the frying pan, like those saucepans. Some of them have got plastic handles. All the things are made for protection from heat because those materials are bad conductors of heat. We ended with under conduction of heat. We ended with an experiment to show that water is a poor conductor of heat. Now, yesterday we looked at convection, and we said that convection is the transfer of heat in fluids from the region of high temperature to the region of low temperature. And I wish you should know, if they ask you to explain convection in liquids, then you should be able to explain very well. Convection is the transfer of heat in fluids from the region of high temperature to the region of low temperature, with movement of molecules, or with movement of matter as a whole. So it means that there are these molecules that transfer heat from the region of high temperature to the region of low temperature. And also you should remember that if water or if a fluid is contained in a container or a vessel, and that vessel is put on a heat source, or there's some heat that is applied to it, then the molecules that are next to the heat source will absorb the heat energy. So molecules that are closer to the heat source gain the heat energy, expand, become less dense, and rise. I wish you could answer if they ask you to explain how convection happens in liquids. You should say that if a liquid is heated, molecules which are closer to the heat source gain the heat energy, expand, become less dense. All these points are important. Gain heat energy, expand, become less dense, and rise. While the denser cold molecules or particles at the top of the liquid fall down or move down to replace the risen hot molecules. In the due process, the convectional current is created. So they will ask you what, they will ask you what is convectional current, and you should know that convectional current, this is the continuous movement of heat from the region of high temperature to the region of low temperature. where molecules that are close to the surface absorb the heat and rise, and those at the top, and the cold molecules at the top fall down to replace the risen molecules. So convectional current, it is the continuous, it must be a continuous process, or it is a continuous process or cycle where hot molecules gain heat and rise to the top of the fluid or of the liquid surface, and the cold molecules fall down to replace the risen molecules. So maybe we are going to start with that as a point to note. Then afterwards, we are going to look at convection in gases. We did this experiment yesterday, but today we are going to look at convection in gases. So the first thing, before we write the heading convection in gases, so you should write here a note like this, and you write convectional current. Convection current. And what is convectional current? Okay, convectional current. Then we are going to give the definition. Convectional current. So this is a continuous is a continuous process. It is a continuous process in fluids where hot molecules of the fluid gain heat and rise while cold molecules move down to replace the risen hot molecules. So you can write the definition in your own words, but you should know what convection means, that we shall have that continuous process. Or if you don't say process, you can say it is a continuous cycle. Are we together? That continuous cycle in a fluid where hot molecules in a fluid gain heat and rise while cold molecules move down to replace the risen hot molecules. So that process continues, and it's what we call the convection current. So then we can look at convection in gases. Convection in gases. Underline. Convection in what? Convection in gases. Okay. Let me see. Okay, yes, you're 5. All right, so let us proceed. So they are saying that what is convection? What does this convection in gases, what does it mean? How does it happen? Now, members, I should tell you this, that you have already experienced convection in gases. You have already experienced convection, and convection happens in the way that the hot molecules of gas, once they gain the heat energy, what will happen to them? They will expand, become less dense, and rise. When air is heated, it expands, the molecules expand. They become less dense. Anything that expands becomes what? Less what? Less dense. I can give you a scenario here. You have seen some people who are very fat and others are very small. But you may find that the one who's very small is even having a larger mass than the one who's fat. Do you know that? Hmm? Do you know that? Because sometimes some people who expand, they become what? They become what? Pav. Pav. People who expand become less what? Become less dense. But anyway, let us leave human beings. Excuse me. And let us look at a balloon. Once a balloon is filled with air, it expands. And then it becomes what? Less what? You like balloons. Dakia, don't you like balloons? Dakia.
Yes,
Don't you like balloons?
I like them.
Yeah, you wait. I've invited all of you for Christmas. When you come, you find balloons everywhere. So even at your home, some of you have balloons, Bridget and Elizabeth. So you have balloons. Those balloons, once you fill them with air, they expand and become less dense. So even air, the molecules of air, once they gain the heat, they expand, become less dense and rise. And what will happen is that because the air particles that have absorbed heat have expanded and have risen up, then it means that at the bottom there is a vacance. So there is no air. So for that place to have air, then it means that the cold molecules are the ones which are going to move in and replace those risen molecules. So when they replace the risen molecules, the risen molecules also the cold molecules will also be heated and they will also expand. So this is what they are saying, that particles of a gas can move from place to place. Air, wind, it moves from place to place. Sometimes wind, the air can be very cold, sometimes it can be very hot. So you should know that it is because of the flow of heat within those what? Within those air molecules. Those air molecules absorb heat. So convection in gases occurs when particles with a lot of heat energy move and take the place of particles with less heat what? Energy. So what you should know is that you have seen people gathering around fire and the air around there is warm, it is hot. So that air which is hot, it is heated and rises up. Now, whatever is there is cold. The higher you go, the colder it becomes. So the air above there is cold. So that air has to fall down because there is some reason air that has gone up, that cold air falls down. And then that cold air replaces the risen air which went up. So also in gases, we have what we call a convectional current. And this convectional current occurs when hot air is heated, it expands and rises. Because hot air is less dense than cold air, that's why it rises. And when it rises, the cold air now falls down to replace the warm air. And this cold air is also heated. So in this way, a convectional current is created. It is created. So in our books, we should write that convection in gases, and I'm going to start there saying that particles in a gas can move from place to place. This is the reason. For this reason, air and gases can move, can be made to flow. So I'm starting from here. Convection in gases occurs. So start from there. Convection in gases, convection in gases occurs when particles, members, are we together? Are we together?
Yes.
When particles with a lot of heat energy, move move and take the place of particles with less heat energy. So we should write that. Another point is that when a gas is heated, its molecules, its what? Its molecules expand, become what? Become less dense and rise up. Then you should say that cold, denser air molecules or gas molecules, denser gas molecules fall down to replace the risen gas molecules. Okay? Gas molecules. Then you say that in this process, we can say with this process, we can say in this way, comma, a convectional, there's N here, a convectional current of heat transfer from a hot place to a cold place is set up. Is set up. So that heat transfer will be set up, and that heat transfer is what we call a convectional what? A convectional current. So we do this, something like this here. And we should put here, put here heat, and you say here warm air rises, and here cold air falls down. And this is what we call convection current. Convectional current. So warm air will rise and cold air will fall. So here it is hot, and here it is what? Cold. Okay, now let us look at, we are going to look at an experiment. As write this, we are going to look at the experiment, how to demonstrate convection in gases, convection in gases. But before we start this experiment, I want us to first watch a video about this. Okay, so let me first start with this. Later on, start with this video here. Okay. Okay, let me share with you the sound. Have you finished writing? Have you finished? Have you finished writing? Yes?
No.
Not yet.
Hey, you have not finished writing.
So we're on the drawing.
Okay.
Yeah, when
Okay.
We're on the drawing.
Okay, finish up very fast. We have something like 10 minutes remaining. 20 minutes remaining, rather. 20 or 15. So hurry up. Ten, 20, 4. So you tell me when you're done. You tell me when you're done.
we're done.
Okay. So now remember, you have finished. Have you finished?
Yeah.
Okay.
Almost.
Almost.
No.
Let me ask you. Sean, have you finished? Sean, have you finished?
Yes, done.
Now, Bridget, you are the one who has not finished. Bridget. Okay. Okay, let us see this.
Thanks for joining us. For today's experiment, we're going to use the gas convection apparatus and learn about heat transfer in real-world situations. If you didn't already know, convection is a method of heat transfer in liquids and gases. Energy and matter are moved by buoyancy forces from one place to another.
Okay, they are telling convection is a method of heat transfer in liquids and gases. For us, we know liquids and gases. What's one name given to liquids and gases? One name given to liquids and gases?
Fluids.
Fluids, correct. So it is the method of heat transfer in fluids or liquid and gases. So energy and matter are moved by buoyancy forces from one place to another due to difference in density. So we shall see what causes buoyancy forces. It is the heat, that this heat expands the molecules, and once the molecules expand, their density reduces. Do you get it? Their density reduces, so they become less dense. That's why they are saying a difference in densities. Okay.
Due to differences in density. To demonstrate convection, we'll need to learn a little more about the apparatus first. The gas convection box is a metal box with a sliding glass front and gas exit holes along the top. The setup for use is pretty simple. Place the two glass chimneys into the exit holes, then open the sliding door and light one of the tea light candles.
So she's now
Place it
lighting.
inside the box under one of the glass chimneys and close the sliding door.
So she's now lighting the
Visualize the movement of the air, so
candle.
we will use smoke. Hold a smoldering piece of paper or incense near the glass chimneys.
So now the smoke will
You'll notice
enter.
that as the candle burns, the air surrounding the candle gains thermal energy and expands, making the air less dense than the air in the rest of the box, which creates a
I
buoyant
want you to
force.
observe that.
The
very
hotter
well.
air then rises above the cooler air and out the glass chimney. Cooler air replaces the air inside the box by entering through the other chimney, and a convection current is established. Now that we know how the apparatus works, how can we apply this and find examples of convection in the real world?
Okay, before we go there, let us go back, and I want you to watch this again. So this is where I want you to get to know. So we have that box there, a chimney box. So there are two chimneys. We have one which is here on the right, and the one on the left. So on the one on the left, below it replace a burning candle, so that there is heat below that chimney which is on the left. And then the one which is on the right above, we hold a burning, not a burning, but a
Box
soldering
under
paper.
one of the glass chimneys and close the sliding door. In our experiment, we want to be able to visualize the movement of the air, so we will use smoke.
So we want
Hold
to
a
see.
smoldering piece of
Very good. So we want to see how air moves. When here we have heat applied here. So how does air move? air, how does it move? So we are going to light up a certain stick here, yeah, or a soldering piece of paper. Soldering, it is not burning, but it is producing what? It is producing smoke, and it is held above this chimney on the left, I mean on the right. Now the smoke will do what? The smoke, you are going to see that the smoke,
paper or incense near the glass chimneys.
the smoke keeps on entering.
The air surrounding the candle energy and expands, making the air less dense than the air in the rest of the box.
Very good. So the smoke enters. This smoke that enters falls down, and then once it reaches the candle here, it is heated and rises. So even if, why do we use the smoke? We use the smoke to see the behavior or the circulation of air. Because we cannot see the air particles, is that one. Because we can't see the air particles, that's why we use smoke. So smoke is visible. Smoke will help us to understand how air is circulating from this chimney to this other chimney. This other chimney, which is here, below it there is a candle that is burning. So there is some heat that is applied. So we observe that smoke will fall, and then once it reaches here, it rises. So if smoke is not there and it is only air, you should know that also the air falls, and then once it reaches here, it is burnt, and then it rises again. So the same way how you can see in this.
Which creates a
So
buoyant
smoke
force.
is heated.
The hotter air then rises above the cooler
so
air
the smoke
and
here
out
it
the
is
glass
cold,
chimney.
here it is cold.
Cooler air replaces
and then
the air
once it
inside the
reaches
box
here,
by
it is
entering through
heated,
the
and
other
then it
chimney,
rises.
and a convection current is established. Now that we know how the apparatus works, how can we apply this and find examples of convection in the real world? As everyone knows, fire is extremely dangerous. Building fires can spread quickly and have tremendous energy. As the fire builds, the air and other gases present can rapidly reach extremely high temperatures. Smoke and any gases will therefore become less dense and rise toward the ceiling. Convection is also responsible for the large and small-scale movement of the atmosphere in oceanic water currents. Have you ever noticed how the direction of the wind changes between day and night when you're at the beach? In the morning.
Okay, so let us end there, and then we shall resume this video once again later on. Maybe you can finish it because the time that is left is 3 minutes.
Mornings, the air over the sand is cool from the lack of solar heating, but the ocean remains warm. This is because water has an amazing ability to hold on to energy, thus it takes much longer to cool. So this causes the air to flow in a counterclockwise direction, or a land breeze. But as the sun rises, it begins to heat up the sand. That hot sand then heats the air above it, causing it to become less dense and rise. On the other hand, the same amount of sun over the ocean has almost no effect on the temperature of the water, and the air over the water remains cooler. The airflow begins to move in a clockwise direction, creating a sea breeze. To summarize, convection happens all around us. From air conditioning in our homes to the ovens that cook our food, the gas convection apparatus is wonderful at demonstrating the transfer of heat. So that's a wrap on today's experiment. If you have an idea for an experiment you'd like to see, comment below. Also, be sure to subscribe so you don't miss any of our future experiments. And as always, have fun learning.
Okay.
Really high temperatures.
So you have seen, especially this part here,
Smoke and any gases will therefore become less dense and rise toward the sea.
that there are very many applications of convection in gases, especially how wind moves on the sea. So it changes the direction after a given period of time. So you should know that those people who stay near to the lake shores, they experience what we call the sea breeze and the land breeze. So what you are seeing here is what we call this is what we call the land breeze. So air flows from the land, and then warm air rises. So this is what we call the land breeze. I repeat that. We shall look at it where warm air rises from the sea, and then cold air from the land falls to the sea. So this one is what we call the land breeze. The land breeze. Cold air comes from the land to the sea, whereas warm air from the sea rises. Whenever warm air from the sea rises, we shall see the reason why it rises, what causes it to rise. And also the sea breeze, it is the opposite. So the sea breeze, the warm air rises from the land, and then the cold air comes from the sea towards the land. And that also creates what we call a convectional current. So in the next session, we are going to look at the other experiment, and also we look at these applications of convection in gases. And we have more of other videos that I want you to watch. So don't go away, remain, and then switch back after 1 minute. After 1 minute, come back and attend the lesson. Okay.